And so as we opened the conversation on consumer behavior, trying to study the behavior of consumers, we highlighted that there are two approaches, that are used when you are studying human, what's this consumer behavior. But before I continue, let me just confirm one more time if you can hear me clearly. Are you able to hear me?
Yes.
Oh, all right, that's fine. Yeah, so just a quick recap from the previous conversations. I showed you that uh, the consumers are always assumed to be rational. That is to say, they always aim at maximizing level of satisfaction at whatever given point in time. They want to maximize utility, right? They want to maximize total utility, basically the level of satisfaction. Yeah, and because of that, we also highlighted that they would try to make the choices whenever given options. They would want to make choices that help them to maximize utility or level of satisfaction. At the same time, we made mention that every time you consume a unit, of a certain commodity, there is additional satisfaction that is obtained. And we made it clear that the additional satisfaction is said to be marginal utility. And so we had a conversation on how to calculate marginal utility given one commodity. And also we had another one where we are looking at two different commodities and how to just select. We made mention that the decision rule is the combination that meets the two you know, rules. The first one is when the marginal utility of a certain generic good X is equal to the marginal utility of good Y divided by price of good Y as the first condition. And when we say that the second condition is that the combination that you get should at least fit within the budget constraint that we have. And so this is the generic formula for the budget constraint. And so this is a second condition at the same time that has to be met by that bundle you select. And so we had the different exam questions from the University of Zambia. Most of them, the ones that we use to just cement this idea. So now, as of today, we want to look at another approach of looking at, consumer behavior. This approach is called the ordinal utility approach, right? Or ordinal utility theory. Remember, we had time to talk about cardinal utility. That's what we were talking about last time, where we made mention that utility or satisfaction can actually be quantified or measured using numbers. But this time around, we bring another message. This approach, the ordinal utility theory, it postulates, it has that, it is not possible for the consumers to express the utility of various commodities they consume, especially in absolute terms. They cannot manage to express that in absolute terms. In other words, it is not possible to number, all right? They can't manage to start numbering. They can only do that in relative terms, in terms of comparisons. You can't quantify utility. So that's what the ordinal utility theory says. It says that satisfaction cannot be measured using numbers, or it can't be quantified. This is different from what we looked at under cardinal theory. Okay. Now, there are some of the key assumptions that have to be, met for this theory to work. And the following are some of the assumptions that really have to be made. And I start with the first one. One, it is said that for ordinal utility theory to hold, consumers are assumed to be rational. That is to say, they maximize their satisfaction or utility when they're given the income and the prices of the commodities. So it means at any point in time, if you are given your income, looking at your income that you have, and the prices of those commodities that you want to consume, at any given point, you would want to maximize the level of satisfaction utility. So that's what the first assumption is for this theory to hold. We also has say that utility is to be ordinal, right? We assume that utility is ordinal. That is to say, it is not absolutely, or it is not cardinally measured, right? You cannot measure it. Utility cannot be measured. That is say, that's what we mean when we say utility is ordinal. For that reason, the consumers are required only to order or maybe place a rank, of their preferences for various bundles of these commodities that they're given. So if the consumers are given those bundles, let's say they have to choose between, consumption of maize and also that of beans. Usually, what will happen is that there will be a bundle. Let's say if they consume let's say 2 bags of maize, then they consume maybe 4 bags of beans, like that. Another bundle could be 3 bags of maize, then maybe 5 bags of beans, like that. So these are some of the bundles that we are talking about. So what we are trying to say, this one is a bundle. It's said to be a bundle because it has options, right? A combination, basically a combination, of the goods that you can consume from different, types, right? 2 different types. So you have that bundle. So we call it a bundle because you are consuming from the maize and also from the beans in this case. This one is said to be a second bundle. You are having 3 units of maize and the 5 units of beans as well. We call it a bundle because you're selecting from 2 sides, or it's a combination. So now, we say that what you can do here, you can just rank the bundles. Say this bundle, let's say this combination, the first one, gives me more satisfaction than the later combination, or this combination gives me more satisfaction than the other. So that's the conversation we are trying to hold. You can't really cardinally measure utility. The other assumption that has to hold for the theory to, for this theory to hold, we need to have, we have to assume that marginal rate of substitution, which is basically the rate at which a consumer is willing to substitute one commodity for another commodity so that their level of satisfaction can remain the same. This is called the marginal rate of substitution. Now, the marginal rate of substitution is diminishing, right? That is an assumption. You have not heard this one. Let me repeat one more time. The rate, or how fast, you can substitute one commodity for the other. How fast can you really substitute this commodity for this other commodity, or trade-off between the bundles, or the commodities that you have? How fast can you really do that? So the rate at which you can do that substitution is called marginal rate of substitution. Now, it is assumed to be diminishing for this theory to hold, right? For ordinal theory to hold, then we should have the diminishing marginal rate of substitution. Now, what does this really mean? Now, this simply means that the rate at which one good can be substituted for another in some consumer basket, it diminishes as the consumer consumes more of that commodity, or more and more of that particular good. The rate at which they substitute does decline. You have not gotten this one. Let me repeat one more time using number. Let's say you want to, I gave you the example where we were consuming maize and maize and beans, you have 2 combination or against 4. You had 3 against 5. You have, let's say 4 maybe against 5.5, like that. What you're trying to say is that the more you consume these products, let's say product M, the rate at which you can substitute product M against the B one, which is beans, it reduces as you increase the consumption of maize. And that's very true. All right. The rate at which you can substitute maize for beans, it declines as you keep on increasing the units of maize that you're consuming, which simply means that, this simply means that if you are increasing the number of, say, the units of the bags of maize, let's say at first you had only 1, then you had the 20 of beans. At that point, let's start from that point. You'd be willing to trade off. I mean, you'd be willing to sacrifice some beans, some bags of beans to get more of maize, isn't it? Because you have little of maize, right? And again, if you have 10 of maize, then you still have 20 of that. At that point, the rate at which you can substitute will be declining. It will not be compared as to when you just have only 1 bag. When you have 1 bag, you are willing to trade off and get some more of that particular commodity. That's what the diminishing marginal rate of substitution really communicate to us. Okay. Now, we also have total utility. Okay, we do have total utility as well. This we said is just the amount of level of satisfaction or consolidated, just that put together. Yeah. So now, that's that. Any question?
I'm fine up to here.
All right. So is there any question now? Any question? Questions can be picked. No question. Confirm you can hear me and you can see the screen.
I can get you.
All right.
Yeah, I can
That's
see
fine.
this.
Okay, that's fine. That's good. So now, then that has us to another level of conversation where we're talking about the indifferent sets and the different maps. An indifferent set or schedule is basically just a combination of the goods and the services which a consumer is indifferent. Just like, that schedule we are seeing for total utility, for this good and for the other, that's the conversation. So this time around, you have 2 commodities, right? Oranges and bananas. You are consuming these numbers. Let's say for oranges, the numbers are increasing as you move to the right. But if you're observant, you would see that at point number A, these are different points. So these are bundles or combinations, right? The combination number A or A would show that you could only have 1 orange if you consumed 10 bananas, right? At this point. When you reduce the number of, or when you want to increase the number of oranges, let's say to 2, then you see that the number of bananas that you're consuming will reduce to 6. When you further increase the number of oranges that you're taking to 4, also the number of bananas that you're taking further decrease. If you decide to increase the number of oranges you're taking to 7, you will see that at that point, you'll only be able to purchase only 1 banana. So what does this communicate? It simply means you have your income, whatever amount you have, let's say 50 kwacha. So now, since you are limited by your income, you have to make a choice, between these commodities. How many of these can I buy so that the remaining money I can buy this other, all right? So as you increase the consumption of the other commodity, then you are reducing the quantities of the other commodity that you can consume at that point. There is that kind of a trade-off that we're talking about, okay? This is called an indifference schedule or an indifference map. That's what an indifference schedule or map means. It's just basically the combination, of those goods that can be consumed at the same time, giving you same level of satisfaction. All these points, they give you the same level of satisfaction. If you consumed this, you would still be happy. You could have one banana or 10 bananas and one orange, you would be happy. Or maybe at this point, you could also have 2 oranges, 6 bananas, or, 4 oranges, 3 bananas, like that, that level of combination, Yeah. Now, observe that at this point, we are also bringing what you call an indifference curve. Now, an indifference curve basically is a graphical expression, of this relationship that we're talking about, or of the indifference set, right? When the indifference set has been graphically depicted, what you will see is what you call an indifference curve. So if you are to graph these, in other words, put maybe oranges on the vertical axis, and on a horizontal axis, you put maybe bananas, let's say, for that matter. And then graph these combinations, you understand? What you will have is something, there'll be a graph, that will come out like that. Yeah, that will be a graph. And that graph is called an indifference curve. Is that clear? If you graph these points on one, yeah, they'll produce a graph. Now, when you observe this, you will see that these points can be graphed only on one graph, right? And you have one graph. These points can be matched properly, and you have an indifference curve. Now, if you bring together, several indifference curves and put them together, you have something that is called an indifference map. So an indifference map simply means the indifference curves are put together, several of them. So this is the curve that I was talking about. The previous schedule, or the indifference schedule that you had previously, it has been plotted on a graph, basically, for the bananas. You can see, and the oranges on the horizontal axis. So this is what you call an indifference curve. Now, if you put the indifference curves, several of them, like many of them, you have many of those indifference curves at different levels, then you have something like this, and this is called an indifference map. Is that clear? Okay. At least you have known the difference between an indifference curve and an indifference map. Your question should be now, what are some of the properties of the indifference curves, right? One, the indifference curves have a negative, slope. That is to say, they are downward sloping, usually to the right. We are trying to say, communicate, we are registering that the indifference curves are downward sloping like this, indifference curve. You've seen, eh? Downward sloping to the right, not upward sloping. Normally, they are downward sloping, they're curving like that. Okay, that's one of the property of the indifference curves. So they are negatively sloped, all right? Why? Maybe that should be the question to be answered. Why do you think the indifference curves are negative, or they are downward sloping? Response. The indifference curves are downward sloping because of the level, or because of the trade-off that happens, in those bundles that you're consuming, right? Because, when you consume this particular commodity, when you increase the consumption of this particular commodity, then you'll have to reduce the consumption of the other commodity. right? So in other words, you can say, in order for you to keep the level of utility constant or the level of satisfaction the same, then the quantity of one commodity is, when the quantity of one commodity is increased, then the other one does decrease, right? That is the reason as to why the indifference curves are curving like that. They're downward slope, sloping. I have explained the reason as to why the indifference curves are downward sloping. I said because of the trade-off or because of the opportunity cost, that is there when you're making these choices, right? That is to say, to be very precise, for you to keep the level of utility constant, then the consumption of one commodity, the increase in the consumption of one commodity would result in the reduction of the other commodities consumption. Okay. What could be the other property of the indifference curve, apart from that they are downward sloping? The indifference curves are convex to the origin. So that is to say, they are convex, they curve like that. That is what we mean by convex. Because if we draw something like this, this is concave to the origin, but them are convex to the origin, right? That's what that means. That's the shape of the indifference curve. Now, the implication is that the slope of an indifference curve does decrease. Of course, this is in absolute terms. As you move along the indifference curve from the left downward to the right. That's very true, that the slope does decrease as you move like that. That's why it is convex like that. Because if the slope, for example, is not increasing or is not decreasing, then the line would have been a straight line. You understand, or it would have been constant. But since there is a decrease like that, it is up, it's increasing, then it decreases, the slope decreases like that. Yeah. So for that reason, you have the curve that is actually convex to the origin. Now, a higher indifference curve is usually preferred to a lower one. Why should that be the case? Okay, this is because, a higher indifference curve, denotes higher utility. So the higher the indifference curve, higher indifference curve denotes higher, level of utility. So as a result, since we have already scored that the customers would always want to do what? To increase the level of satisfaction, always to increase to maximize utility. Then when given the 2 points, the one that gives a lower level of satisfaction and the other one that gives a higher level of the same, they would opt to go for the same, right? They would go for the one that gives a higher level of satisfaction, so that this can be properly in obedience to what we have already said, or to the concept of rationalization. We say that the human beings are rational. They always want to optimize utility. Did you pick this one? I've already said, number one, that the indifference curves are downward sloping. Number two, they are convex about to the origin. And the indifference curves that are higher, right? If you're given 2 indifference curves, this one, the first one, IC1, and the IC2, indifference curve 2, indifference curve 3. Indifference curve 3 will be preferred to 2, to indifference curve 2, and 2 would be preferred to 1, all right? We always want higher indifference curve because they are trying to show a higher level of satisfaction. This is the ranking that you're talking about. Are we good? Is there any question there? This is very straightforward, yeah? Can you still see the screen? Are we still connected?
Connected.
Oh, all right. Thank you. So let's continue now. So now, the property number 4, indifference curves never cross each other. They cannot intersect again. This is important to take home. Indifference curves would always be parallel to each other. They would never cross. You can't have indifference curves like this. That's what that means. This you cannot have. They don't touch each other. They don't intersect. They don't cross. That is the assumption, all right? Now, why should that assumption hold? Why should the assumption hold? The assumption of consistency and transitivity will rule out the intersection of indifference curves. And I may be aware that you people are not conversant to the assumption of consistency and the transitivity. Let me just show you what we mean by that, all right? You can see the screen, you can see the two indifference curves that are crossing each other. Now at this point, point A, at point number A, if you check the way how point number A is, point number A is on two indifference curves, yeah? It is on indifference curve number 1 and indifference curve number 2. We do know that indifference curve number 2 is higher than indifference curve number 1. And from what we said previously, we said if someone is consuming at point B, which is on curve number 2, then that level should be preferred to any lower level, right? So check B. B is on a higher indifference curve, which means it's preferred, right? At the same time, A is on the same indifference curve with B. Now, all the points that are on the same indifference curves, they are option. They give the same level of satisfaction. That's what that means. So A and B, they are equal if they sit on the same indifference curve. But again, A belongs to the two indifference curves. You've seen. It belongs to the one that is higher and the other one that is low on the lower indifference curve. So if you consumers prefer, let's say, bundle B, of course, it has to be like that because B is higher than C. Then on the other hand, the following indifference curve, if you check the indifference curve number 1, the consumer is indifferent between A and the C. And along indifference curve C, the consumer again is still indifferent between A and B again. Now, according to the principle of transitivity, it implies that the consumer is indifferent between point A and what? A and B, which you cannot really hold. You can't be indifferent between higher level of utility and the lower one. You get it, eh? We have already assumed that the consumers would always want to consume at higher level of utility. They cannot be indifferent, between a higher one and a lower one. That's the reason as to why we say the indifference curves cannot cross. Please, you should pick that explanation and you should work with it. Okay. Why shouldn't the indifference curves cross? That is the explanation. Marginal rate of substitution is what we have already talked about, is the rate at which one bundle can be substituted for the other, right? And it is basically the number of units of Y that are given up, basically the change in the consumption of Y, also divided by the change in the consumption of X. And this gives us the marginal rate of substitution, all right? And this is the message that we are actually sending, right? Okay. Now, there is nothing so much to to really highlight here, we're just trying to say that the marginal rate of substitution is basically equal to the slope. And the slope is found by saying marginal utility of good x divided the marginal utility of good y. Or in other words, the negative change of good, what is this? Good x divided by the change of good y. That as what we did previously. If you have an equation in calculus, two equations in calculus, you need to calculate for, you have the equation for y and the equation for good x. You do need to find the derivative, the dy over the x, right? Let's say the x over the y. The x over the y. The x over the y. This is basically the marginal rate of substitution of y and the x, all right? But if you say dy over the x, this is again the marginal rate of substitution of x comma y. Dy over the x, meaning the change of y as a result of a change in x divided by change in x. So all this understanding is very important. We mean the same. You have not heard this one. Let me repeat one more time. If you are asked to calculate the marginal rate of substitution, you're basically finding the slope. And finding the slope simply means if you are given marginal utilities, right? Marginal utility of x and marginal utility of y. If you divided them like that, what you have, it is the marginal rate of substitution, of x and y. You get it, right? At the same time, if you do the reverse one, which is the marginal rate of substitution, y, x, substitution of y for x, it is equal to now marginal utility of y divided by marginal utility of what? Of x, like that. That's the difference. You've seen, it's just stripping this equation, the inverse of each other, the inverses of each other, all right? So using this concept, this is what you pick. Now, if you have numbers and I take it that you already understood on how you find the marginal utility. If you have a list of a number, a schedule, right? Schedules, you have total utilities, you know how to find the marginal utilities for both of the commodities. That is still fine. Now, this time around, there is also an idea of, we also need to look at what if you're not given numbers, but you're given an equation. So the equations for good x and good y, right? Let's say you have the utility function, of x comma y that has got these variables. You have to differentiate these. To differentiate this so that you can find the marginal utilities, all right? So for example, dx dy, meaning the differentiation of the function with respect to y, it is same as, marginal utility of y divided by marginal utility of x. This is equal to the marginal rate of substitution y comma x. You need to take this home, very important. And if you do the reverse, you can say dy dx. This is the marginal utility of x divided the marginal utility of y, and this should be equal to the marginal rate of substitution, of y comma x, meaning substituting y against x. Okay. Now, with all these substitutions, then it is important to record the concept of the indifference curves. And the indifference curves are very important to take home, right? So we need to introduce the budget lines now and the pricings. Basically, the budget line is the budget line is given by this. This is similar to what you had in the previous class. You remember budget line. We are saying the budget line is income equal to the price of good X times the quantity of good X plus price of good Y times the quantities of good Y. This is the budget constraint. This is the equation. So if you want to pick the intercepts, for example, the intercept, look, this is your budget line, right? This line. You want to pick a number here, the intercept on the Y this side and also on X this side. For Y, it will be given as income divided by what? Price of good Y minus price of good X divided by price of good Y times good X. That automatically will give us what? The intercept on Y. And if you do the reverse, which is X, it will give us the intercept on X, which will be income divided by price of X minus the price of Y divided by price of X times Y, the quantity of Y here. And this is how it will come out. So the budget line is very important. You need it. You need to understand the budget line. It is drawn like that. So in intercepts, basically, it's just as good as saying income divided by price of good Y. Also this side, just say income divided by price of, good X. Why should you do that? Because the quantity of the other commodity, when you're looking for the intercepts, is zero. So everything declines to zero for the other side of the other part of the equation. So just remain with the first part where income is being divided by the prices. Now, why should you need the budget line? The budget line, basically, we have it because your level of utility has to be controlled, right? It is managed, okay? It is actually controlled by your budget. So let me just give you an example. For example, if a consumer has the total income, remember our budget line is income is equal to price of good X times quantity of good X, plus the price of good Y times quantity of good Y. You're following that, eh? That's what we say the budget line is. So your income is, let's say, is $100, and the price of good what? Good X is 3, so it will be 3 times X, plus price of good Y is 5, so it will be 5Y equal to 100. So at that point, if you want the intercept, the value of Y or the value of X, you just make that Y the subject of the formula in this equation. That's the message we are sending. Eh? So if you want Y, you will set X equal to 0. At this point, because at this point, the intercept X is equal to 0. So you say 100 equals to 3 times what is your X at this point, at the intercept? This is 0, right? Plus 5Y. So since this will be 0, you just divide 100 divided by 5 like that. That's how you get this 20. Then you do the same, the reverse when you're doing for X as well, which shall be, 100 equals to 3X plus 5Y. And you say the Y at this point at the intercept is 0 as a quantity of Y. So you just say, so for X, so that X can be equal to 100 divided by 3, and you have this, the 3.33. This line you have plotted now is called a budget line, right? That's the budget line that we are talking about. It's very, very important to learn how to graph that. So if the budget increases, like the income increases, you will see the budget line shifting outward like that when you're plotting. it will increase outward. And again, if the income reduces, the budget line will shift inward, showing that the income has what? Has reduced. And that really affects your level of choices that you actually do make. Then at the same time, there is also the idea of prices changing. Sometimes income may be the same, but prices may change. So if, for example, there is a reduction in the price of X, good X to 3, from 5 kwacha to 3 kwacha 1, then the budget line will tilt inside to show you that the commodity has become cheaper. It will tilt on that side. If we good Y, let's say Y is the one that has decreased. At first, this was the first indifference curve, right? It reduces from, let's say this was 7 to 5. The indifference curve would tilt towards this. This is the tilting that I'm talking about. It will reduce like that, okay? Oh, is this a reduction? Sorry, this is a reduction. If the price reduces, then it will shift outward, like it will tilt outward, showing that this will be an increase in the level of the satisfaction, because there will be an increase in the quantities of good that you're going to get. When prices reduce, the shifting and the tilting of the budget line, if the prices decrease, the tilting of the budget line is outward. But if the prices increase, the shifting will be what? Will be inside. Okay, the tilting will be inside, because that simply means that now the price has become very expensive. The prices have become very expensive, and so you need to pick that message as well. We'll try many questions for you to be fine as we'll be trying to cement this idea. And in general, at optimal, as we conclude, at optimal point, the optimal point in ordinal utility shall be that point where the budget line is tangential to the indifference curve. Since you have different indifference curves, remember indifference curves just shows us the levels of combination that we should pick so that our satisfaction can be maintained. So the only indifference curve in this case shall be indifference curve 2, because at this point, this indifference curve is tangential, or it is equal to our budget, our capacity. Indifference curve shows level of satisfaction, but budget dictates capacity. So when capacity is met by the desire, then you are at the optimal point, which is point E. So this is the message that we are sending. So at that point, you find that the slope of the indifference curve, which is marginal rate of substitution, it is actually equal to the differences in the prices. If this is X for Y, this will be the price of X divided by the price of Y. If it is marginal utility, then you say marginal utility of X divided by marginal utility of Y shall be equal to price of X divided by the price of Y. It is another condition that has to be met at this point, at point E. That is what happens, which is at optimal point. Okay. Otherwise, there isn't much that is being conversated on. Yeah, the unit ends like that. So we need to come and try more questions in the next conversation, so that we can come and introduce production theory, which is the second last topic, set of conversations in microeconomics.